So what's going on, guys? So we're talking about some tools for the modern web developer. A lot of you probably have some preconceived notions as to what those might be. A lot of you will probably be correct. Some of you will probably learn about some things that you haven't heard of before. So hopefully you come away with this learning a little bit of something. So here's a fun little tweet from the I am developer. So this is pretty accurate if you've ever tried to make a full application with JavaScript without a precompiler or any sort of tool in between. You definitely could qualify as a psychopath. So, a little bit about me. My name is Brandon Cash. I'm a lead developer at 40 Digits. I'm a JavaScript enthusiast, an open source software advocate, and I just generally like build tools. They're very interesting to me, and there's lots of them. So here's the old school way that has been around for years and years. It's still tried and true. Some people do it. It's a pain in the ass, though. So you start with your met input, you go through your met transition, and then you end up with your met output. So what's some issues with the old school way? Well, you have to write straight CSS, JavaScript, and HTML. So that means you don't get access to any bleeding edge features. You don't get access to all sorts of crazy new syntaxes, different languages, etc. So deployment is usually just copying files. A lot of people FTP them. You can just stick them in a Git repo, stick them up there, or pull them down wherever you need, and then it's just good to go out of the box. And it always works. Everything really tries to boil down to this point. You just don't have to write it that way. So maintenance becomes a nightmare because if you have to add features to other old features, suddenly you get a lot of bloat where you're ending up having to edit multiple files, or you're having to edit the exact same thing in like 30 different spots, just because you didn't have a tool that did that for you automatically. So you do have to also manually manage your packages, your assets. So anytime you have to crop an image, minify it, reduce its size, all of that stuff you'd have to do manually, whereas Build Tool might be able to do that for you. So here's the new way. You take your happy input, you go through some Shia magic, and you end up with some happy output. So for reals, build environments really only have two pieces. And so one of those are compilers and transpilers. These things really just take the code that you want to write, transform them in some way, and then spit them out in another way. Helpers are just time savers, things that you do commonly, things that you're going to have to do that you might not want to do, some things that really just make you more efficient or a better lazy person. So it's really easy to write one thing one time that does the exact same thing over and over, and then just have it kind of do that automatically for you. Saves you tons of time. So what do build tools introduce? Really, it's kind of open-ended because build tools is not really a specific thing. But key, I would say, is developer happiness. So that makes you, the developer, want to write the things that you want to write. So as I mentioned earlier, writing those just stock HTML, JavaScript, and CSS is not very fun. So with these things, you can write in like Sass, CoffeeScript, basically any language you want, and then it'll convert into the final web deliverable product. So you get access to a lot more powerful tools. So in CSS, you can't do things like nesting, but if you do like Sass or Stylus, you can easily nest to your heart's content. And so the features like that just aren't available in these stock browser languages, and it makes it a lot easier if you have access to those. Package management is another very crucial thing. So there are tons of JavaScript libraries out there. It's very easy to get them out of date. And it's very easy to get tons of them, and it's very hard to keep those things constantly correct. But with a lot of build tools, you get just access to those things pretty readily. So rather than going out, finding a minified version of jQuery or something, dropping it into your DOM, you can instead just pull it down from NPM or Bower, and then you just have it there ready to go. And you can compile it into your final product. Debugging-wise, there's all sorts of things that you can get. Typically, you have a console running with kind of what's happening as you're building your project. A lot of times you have access to live logging of the actual server. Some build tools actually have a server built in with them, and so that'll actually host the files for you, give access to those files through your web browser. Automated tasks, we're going to talk a lot about later on. So these are just really things that you do constantly over and over and over again, and you just want to do them once, figure out how it's done, and then just magically do it everything else. And so these things can really broadly range from rebuilding a JavaScript when you save a .js file, making a sprite sheet out of many different images, turning SVGs into a web font. Really, it's just open-ended as to what makes sense for your project. And there's tons of libraries out there that do literally anything you've thought of. And if not, somebody wants that, so you should make it. So file bundling is another big one. That's a big way to increase your browser performance. So instead of going out there and fetching like tons of different modules because it was easier for you to develop that way, you can write that way where they are split apart, but then kind of bundle them together. And that way your browser only has to download that once, it caches it, and then every subsequent reload, it's just ready to go. So then your whole application performs a little bit better. So where do you begin? Well, you start with the task runner. So there's all sorts of task runners here. This is by no means an exhaustive list. And really you can use anything that just runs commands. A lot of these are a little more intelligent than that. They know kind of which way to manipulate these things in the way that you want. A lot of them are really configurable, but really it all just boils down to running commands that you want to run. So some of the task runners are gulp, grunt, Webpack, broccoli, mimosa. A lot of people use like npm. You can use like a batch file if you want, sh script. It really doesn't matter, it's just whatever makes the most sense for you. We'll go over a lot of these here in a minute. So one nice thing that you can do with this is bootstrap a new project. So a lot of times you can just say like init, and then it just pulls in a default configuration file for you. That can do all sorts of things for you. It could pull down all of your dependencies. It could pull in, or it could scaffold an entire application for you. It could start up a Laravel application if you wanted. Basically just set you up with a boilerplate with just one line. So one big important thing is that it can watch files for changes and run the proper tasks. So I mentioned earlier, if you like save a .js file, probably you want to rebuild your JavaScript and see how it works. Or at the very least, see if it triggers any errors causing your build to fail. So if you want to have that running, you can just basically tell it to watch JS files for changes, CSS files for changes, and anytime you save those, just recreate them and then put them on the new site. So you can run bulk operations. So one thing I mentioned earlier was taking a bunch of images and turning that into a sprite sheet. That's a really common one where you could just take an entire directory of pre-made images, drop them in there, generate some code, and then boom, it's automatic, ready to go. And it really is that easy a lot of times. They're configured for your project. You can start with a generic configuration, but really if your project is different from any other project, you should probably try and find a way that works for you and your developers. There is no one tried and true best method. Really, it's going to depend on what your best workflow is. So another very important thing is that it's easily run by other developers. If you make a build script that's so complex that nobody can figure it out, nobody will figure it out. And they're going to end up modifying your compiled CSS and JavaScript. They're going to have a terrible time, and then you're going to have to maintain that. And you don't want that, so try and use something that's easy to understand, but at the same rate gives you a lot of efficiency, and basically just tries to set up the project the way you would like it. So gulp is the forefront of build tools right now, or the task runners. So what gulp does is pipe files into modules. So basically it just takes one source file, goes through gulp, gulp does whatever it needs to do to it, transforms it, and then spits it back out. So just think of it like a pipe. So one thing goes in one way, something happens to it, and then it comes out the other side completely different. It's got a huge community, tons of modules. Lots of pre-made boilerplates, so there's a lot of things that have like Angular and gulp running in them. You can get all sorts of different frameworks pre-set up for you. There's just really tons of those on GitHub. If you wanted to try out gulp, really you just search gulp boilerplate and you'll find 20 of them. Gulp is my personal favorite. It's a little bit faster than grunt, I've found, a little more configurable. And one big key thing is that it is configured by actual JavaScript code rather than like a big object. So you can actually manipulate the way that it is already manipulating things. So you could have it do something one way as the default way and then have your own stuff kind of manipulate that on top. That's a little bit harder in grunt, which I'll show you here in a second. So this is a sample gulp file. So this one just sets up a couple tasks. So some common things you might want to do is build, and then down here at the bottom I have Reactify. And Reactify is really just watching these .jsx files for changes, and then running build. And so build here is pretty easy to read through if you just kind of read it line by line. It's just taking files with these certain extensions, transforming them. Here it's doing some ECMAScript 2015 and React stuff. Bundling that all into main.js and then writing it to the file. And really this works just out of the box with this alone as a gulp script. And so with this alone you can run JSX transforms on your code and it's going to actually build into that file if you want. So with grunt it's a little bit different. It's configured with a large object rather than these small code modules. So you have less ability to configure what happens when you invoke a task, but you do have a little bit more configuration options that go into each specific module or task that's kind of pre-made for you. It's also got a really large community. It's pretty active in development, less so than grunt now, or less so than gulp now, but it's still a very active community. Tons of libraries available for it. So if you wanted to write in different languages, there's probably support for both grunt and gulp. So here's a sample config. Obviously it's a little bit longer. You'll notice that it's just an object really running into this init config. So in that way it's a little bit different, but really these do about the same thing. It's just taking JSX files. It's going to output a .js in the end. So another one is Webpack. This one's really picking up a lot lately. So it's configured with JavaScript and NPM scripts. So basically you write code and then you invoke them with NPM. So it's built around resolving dependencies, and that's kind of language agnostic. It's meant to say if you want this thing regardless of what you're doing, styles or JavaScript, you can really just ask for it, and then Webpack is supposed to kind of figure out how the dependency tree works and then give you a nice clean bundle in the end. So it's really relatively new. The community is very, very active right now. It's really starting to boom a lot lately, and I think here in this next year we're going to hear a lot about Webpack. Probably both good and bad. Just is a little bit different than all the other ones, and I'll touch on that a little bit later. We'll see. So here's a sample Webpack config. This one's doing CoffeeScript, and so it's got some ES 2015 as well and React. So basically all of these three configs did the exact same thing. They just took JavaScript in, transformed it some way, and then spit it back out as an actual runnable JavaScript library. So here's a little popularity chart that I stole off the interwebs. So obviously gulp is the big chunk of this chart. Don't use one is the next highest one. So I guess most people that took this survey, this is like out of 13,000 developers, that was a really large chunk, I thought. But my guess is that they don't do a lot of large applications, but rather do small modules that you can just drop in a script tag. Probably a lot of like jQuery, just simple stuff. But grunt obviously is another huge one there. It probably 2 years ago, the green and the blue would have been swapped, and that'll probably continue to be on that trend as gulp continues to grow. It's actually a little bit higher than this now. This is from last year. Then broccoli was kind of big for a little while, but is a tiny little sliver. NPM's picking up a little bit, and it's just Node package manager, so you can just write little scripts in it, and people seem to enjoy that now. Next you need to pick your tool chain. So there's compilers, transpilers, and then there's pre and post processors. So these are a crucial step in making you a very happy developer. So they take many languages in and put one language out. So if your end goal is HTML, CSS, and JavaScript, but you don't want to write any of those things, then you get one that turns something into HTML, something that turns something else into CSS, and something that turns something else into JavaScript. And there's really tons and tons and tons of things you can choose to do those. I'll touch on a couple of those here in a little bit. But the bottom line is that you want to write these things because they're just newer, nicer, and they'll save you a lot of time and sanity. For JavaScript, a really big trend lately is to stick with the brand new bleeding edge JavaScript that has been completely accepted. It is the new JavaScript standard, so that's ES 2015. There is ES 2016 as well, and then it'll just continue to iterate every year. So you can use Babel to transpile that brand new code into ES5. So ES5 has great browser support, whereas ES 2015 is really not great. So Edge is the only browser that supports pretty much anything very well right now. So basically, you just write JavaScript and turn it into JavaScript, but you can just write newer stuff before it's actually in. It's not exactly perfect yet. It probably won't ever be, but it's a really good patch if you want to write the current standard and then just flip a switch later on, and then suddenly you're up to date. So some other ones you can use are TypeScript, CoffeeScript, LiveScript. There's a lot of blank script. Pretty much anything like that is ECMAScript. A lot of them do have compilers for JavaScript. And if you wanted to find any of these for gulp or grunt, really it would just be searching gulp TypeScript, gulp CoffeeScript, and you're going to find at least one very well-maintained version of that. A lot of these have neater syntax and a lot of just really brand new features. The new JavaScript standard has a lot of things that people have wanted for years and have put into these other languages. For instance, like CoffeeScript has this fat arrow that is now in ECMAScript, and people love that thing, and it's been in CoffeeScript for years. It's been an action script for Flash development, and it's just really nice to have those features. They do have niche communities, so there's a lot of like Slack organizations, IRC channels. You can go and talk to these people that develop these things. A lot of forum chatter all over the web. So really, it's not hard to find people that write in any of these languages. It's probably actually more common to find a new developer that writes one of these than JavaScript. Hopefully they know both, but these are probably going to be more popular all over than JavaScript itself.
Question. Could you do me a favor and restate which browser it was that supported all this modern JavaScript stuff?
Oh yeah, so that is Microsoft's Edge, and it is by far leading. So they're crushing everybody else in browser support right now.
And it's written in Java, so
Just need to make sure I heard that right.
Yeah, no, they are crushing it. Okay, so for CSS, the big forefronts are Sass or SCSS. Those are really the same language, but quite a bit different. There's Less, which is pretty identical to SCSS. Stylus, which is an affront to nature, but pretty effective. So really, these things just turn these languages into CSS, just the same way that JavaScript did. So these also introduce new syntax. The biggest one I think a lot of people use is nesting. So that's just putting a selector inside of another selector. It kind of seems natural that you would write it that way, but CSS doesn't support it yet. Another big feature is that it lets you not repeat yourself, so follow the dry principle. So that way you can do modules, functions, all sorts of little tiny things, again, just reusing things that you commonly do. So if you don't want to write it 20 places and then have to fix it 20 places later on, write it once and include it. And so you can't really do that with CSS. I mean, they're getting a little bit better now, but for a couple years, it's probably going to be this way. So you take the modular approach because you can split things out into many files, whereas with CSS, you probably have to write one really big, long file, or kind of just manually pick which selectors you write in files, and again, you'd have to manage those manually. So it has a lot easier support for old browsers. There's like auto prefixer, where you can just basically flip a switch and say, I want IE9 support or something, and it'll try and adapt your CSS. You can add a little like -ms, -webkit, -moz, kind of give these CSS features that browsers have had in this experimental phase, but might not support the bleeding edge CSS standard. So there's tons of options. This is by no means an exhaustive list. So show of hands, how many of you use at least one of these things on the board? I'm actually surprised it's only like maybe half. How many of you use one from at least 2 columns? How many of you use one from all 3 columns? All right, so we got a pretty fair assortment here. So there's all sorts of different versions of things you can use to compile. Some of these are a little bit interactive, like JSX could probably also be in the HTML column, just because it's a little wonky. I don't really use much in the HTML column, but I'm a big fan of Sass, ES 2015 React stuff. Really, what you want to do is up to you and your developers. There's no one best way. It depends on what you want to write, what the best way for you to write it is, and what's going to make you reach that end goal a little bit better. And pretty much anything on this board will be supported by any of the things that I mentioned earlier, like gulp, grunt, Webpack. You should be able to stick all of these in there. Somebody's going to have a module that they're keeping up to date. And so really it'll just be as simple as saying, oh, I want to write Haml in this library, but I want to write slim in this one. You can configure your task runner to do specific things based on how you want to do them. So you could have any of these things running side by side. You could easily swap them out later on. Obviously, you'd have to rewrite the source that it's reading, but you could do it. So really, it's very modular. And the things that it compiles to do end up as usable code. I mean, you can edit them. It's probably going to be terribly ugly, but if you wanted to, you can, because it's written for a browser. So here's some support for, or how many people use that. This is the same group as the previous chart. So Sass also includes SCSS here, so it's a little bit blurred as to which of those 2 are the largest. But less is the obvious next forefront there. No preprocessor also kind of alarmed me here. I was really surprised by that one, but I kind of figured that was the group of people that did things like Bootstrap and just all of these third-party libraries. Hopefully that many, or that % of web developers out of a 13,000 group is not still writing stock CSS. And hopefully 15% of you will not from now on at least. So pro tip, if you're curious about trying any of these out, go to codepen.io. They support almost everything out of that chart that I had up earlier. And really there's just a drop down. You say I want to compile my HTML with this, I want to compile my CSS with this, my JavaScript with this, and then it's just got little windows you can write in there, and then it just shows you the output. So it's really nice if you want to try it on the fly. So once again, just codepen.io. Okay, so from development to deployment, so you're going to obviously want to bundle and package your things. So what is bundling and packaging? So you use Browserify, Require, Webpack, JSPM. Really these things just take your files and then write them to the end goal. And what that is really depends on what you're doing. So for instance, if you're developing, you probably want a nice debug environment. You probably want source maps. You probably want all of these things that are going to make it easier for you to debug. But then when you go to production, you probably don't want those things there, or everyone's going to see all your terrible code. So really, you're trying to organize the files in the way that makes sense for you and your developers. You want to optimize those files for delivery, like I said, for production or whether you're developing. So you can write completely separate things, or you could always do the exact same thing. So you could have it deliver unminified code, or you could have it minify, reduce images, shrink everything down, bundle it into one package or one .js file if you wanted. Like I mentioned earlier, then you only have to download it once, and then it's cached, so you don't have to do it again. Or you could have it split into multiple files. HTTP 2 is going to come out fairly soon, and it kind of resolves that issue. So hopefully that's a little bit better in the future. But for now, bundling lots of little modules or global modules into one file is always going to be the better solution, unless it's like a 13 meg file, in which case you probably did something else wrong. Yeah, another thing, automatically adds support for features in older browsers. So there's a thing called shimming, which takes support for things that are like Flexbox that you guys might have been here for a couple months ago. You take that, basically insert the ability for that into a browser that doesn't have the support for it. And really that goes mostly for older Internet Explorer, but there's a lot of these shims for all sorts of different browsers. There's like weird quirks that like Safari doesn't do very well. And it's easy just to not worry about those and have your build tool take care of it and transform your code for you. So some popularity here. So don't use is more than half of this chart. That one's actually not as surprising, I don't think. I feel like you'd need to kind of make an application to necessarily need one of these things. It's a little large. I would think most websites would probably just need like jQuery things or like little small snippets that are based on the page that you're on rather than a fully architected out application. So I don't know what these developers did necessarily, but Browserify is the next biggest one. Requires the large chunk after that. Both of those have really great support. I personally use Browserify. I think it's really easy to use. There's lots of great documentation out there. Requires not as easy to get around just because you kind of have to architect a little bit more, whereas Browserify takes care of a little bit of stuff for you. But the end result means that you are writing less and it is producing a nice deliverable for your users. So I mentioned a little bit about debugging earlier. Source maps, those basically take your pre-compiled code. So if you had an error in some of that, but then it got changed into some other code, a source map tells your browser how to understand what happened. So while your browser is running the JavaScript that's compiled, if you didn't have the source map, then it's not going to know where that error actually happened because the code you wrote might not be the code that's running. So a source map will tell you exactly where that error happened, what happened. It'll try and do its best job as to what language that is. So it's really agnostic to styling and script as well. So there's a lot of debug tools you can use for CSS, a lot of debug tools you can use for JavaScript, even ones you can just use for server logging. So a big feature that I enjoy out of most any framework is live reloading. Especially for CSS, if you want to do like little small tweaks and you don't want to refresh this whole page, basically you just save the file, it recompiles your CSS, triggers the change in your browser, and boom, it's there ready to go by the time you have it up. It's really good at catching compile time errors. The build tool that we use at 40 digits throws a little notification, so it's really obvious when that happens if you didn't see something happen in your editor before that. It can do things like linting, code standards. You can get tests run at this point. Lots of editor integration. So Atom and Sublime have packages that can interact with a couple different debug things. So really it just depends on how you like to debug and what you need. So a couple common configurations. So here is my typical day-to-day. So I'm a big fan of Gulp. I use Gulp Edo as a framework. That's a framework that we developed in-house at 40 Digits, which is really awesome. You should look it up if you are curious about any of this stuff. So for CSS, I use Sass. Actually, typically I use SCSS, but it's really the same thing. Use post CSS for adding prefixes. So that's like the -moz, -webkit, etc. We use Babel to transpile ES 2015 into JavaScript. I use JSX mostly on personal stuff at the moment. Not a whole lot of professional React stuff for me. And then browserify to bundle. And then HTML is typically driven by something in the back end, or it's static for me. But that's my typical day-to-day. Does anybody in here use something similar to this? I mean, I know my coworker obviously does, but yeah, just you two? Yeah.
Yes, so.
Yeah. I don't think I had another one in here. Yeah, I don't. Okay, so who in here uses grunt? Yeah. So only 2 as well. 3. Okay. So do you guys use Sass less?
Wish.
Yeah. Do you write stock CSS?
You bet I do.
Yeah.
Groovy.
Is that a large project?
It's nobody's fault but my own.
Yeah.
Well, that's not true.
So it's complex. Like there's a handful of projects where like I'm doing things like web components.
Yeah.
So like for those, yeah, I'm writing stock CSS in this like highly modularized,
Yeah.
Subset system. And the other case is like our global style sheet we use for almost every page on our site, and that was sort of like inherited.
Yeah.
So
yeah.
yes, it's stock CSS, but I didn't have to write it. I don't really update it. It
Yeah.
just exists.
Yeah, so that's something you get into. It is hard to get out of that hole. So especially if you got the deliverable version of somebody's pre-compiled thing, but you didn't get their build tool or their source code. So for instance, if somebody compiles down to CSS and you get this minified version, then you have to figure out a way to resolve that, and it's not usually very easy. Especially making it kind of turn CSS into like SCSS, because it doesn't know how you really wanted to nest those things, because then you lose all of your specific specificity. Yeah. So all this should sound pretty great to you, but there are a couple issues. There is a developer disconnect from the output. It is not very common for a person to actually physically open their compiled code and take a look at it. Typically, you're just looking at the error that it threw and the location that the source map threw you to. So with that, what you write is not what you get, and you don't know how it's going to compile until it compiles, or unless you know exactly what it's going to do. So if you don't know JavaScript, but you do know CoffeeScript, then you write something that you knew well in CoffeeScript, but you didn't know what it writes in JavaScript, and it didn't work how you thought it did in JavaScript, then suddenly you're a little screwed. So you kind of need to know both, but hopefully source maps get you figured out. But you can run into issues. They're not perfect. So you do run into reliance on tools at that point as well. So like we just talked about, if you do compile, then you can't really revert from that. You can't use that CSS as your source now. I mean, I guess you could figure out a way to make it compile to a cleaner version for you, but it's still probably not going to be great. So you're really reliant on the tools, which means you have to maintain them. That's kind of up to you as to how much you want that to go into your projects, because a lot of times you could compile a version of some library hard-coded in there that then they do a big update or something. You didn't have to go in and recompile it. Hopefully your tools are up to date. Hopefully NPM isn't 5 versions ahead at that point, which happens. You also run into some third-party library bugs. Really, if you can't get to the source, or if you just don't understand what's happening, you kind of have to deal with the bug or try and figure it out or get around it. So really, if you run into an issue that you can't resolve, the only thing you can do is open a bug report and hope somebody fixes it for you. So the best thing in that case is either wait it out or find a different library that does what you needed.
You fix it, submit a pull request.
Yeah.
Never get denied 5 times.
Yeah. One guy replies like 3 years ago, says, I fixed it. And that's it.
Yeah.
So you run into dependency hell, which goes hand in hand with the next line. 300 megs of npm packages for a 2 meg app. So this literally happened to me the other day. Somebody said their React app was 4 megs, and I was like, that seems pretty large. I'm going to go see what my current React app is at. And I did not expect it to be 280 megs, but that was a very large amount of JavaScript libraries, I thought. So obviously that all that stuff doesn't end up in the end goal, but the developers still have to download it, they still have to run it, and that's just a lot of stuff to maintain. And each of those things really maintains its own list of packages. If you look at the npm tree, it gets extremely deep, extremely fast. So you have tons and tons and tons of stuff. And again, that goes back into your reliance on those tools. It's very difficult to get out of that rut. So you don't really want to go in and swap out one of these npm packages for like a hard-coded, minified version you downloaded. It might work, but might not. There's only one way to find out. So that's all, folks. So any questions? I don't think I have a next slide, but any questions? Yeah, what's up?
Whenever I try to pick one of these, the fear is always that I pick it and then in 6 months or a year, they're just going to like go, going to be out of business or somebody else is going to be the dominant one.
I mean,
what's some advice for trying to stay on the wave, the popular wave?
Yeah, so that's a hard one. They probably will change, especially in the course of years. So I would assume that in 2 years, none of these things will be at the forefront of my mind. But knowing what they did and how they worked, definitely will be. So a lot of these tools do basically the exact same thing. But now we're starting to see some really just different ways of thinking. So like React is a very different way of writing your code. Webpack is a different way of bundling your code. So really, it's gonna constantly change, and you just kind of have to see what people are wanting to do at the time. So, for instance, how many people here do Polymer stuff? Yeah. Okay. So Polymer, I remember when it landed was huge, like ridiculously huge, and so we have 2 people in the room that use it right now out of like 30. So Polymer is not like at the bleeding edge of everyone's mind right now. I mean, it's still really cool. It's really nice stuff. But a lot of times things do pop up, and then a little while later they're not there anymore.
You guys are switching all the time?
Not necessarily all the time. One really nice thing is that all of these pieces are modular. So if you use gulp, you could probably figure out a way to keep the exact same source and then switch to grunt. You would have to reset up how your configuration works, but it wouldn't be a nightmare. And likewise, it'd be pretty easy to swap out CoffeeScript for TypeScript. You just have to change your source, which would probably be more difficult. But really, it's kind of up to just what developers want to do as to what stays the bleeding edge. There's constantly going to be updates. These ones have all been around for a while. Grunt's a couple years old for sure. People still use that, and it still works great.
It's practically ancient.
It really is compared to like gulp, and like Webpack is really like a year old, so or at least in popularity. Okay, what's it?
I'd just be curious to know, none of this seems applicable to commercial code base because you guys have been apps stick around for 10 years. It seems pretty, if you're making it for a business web page or something, yeah, great. Pop it out there, it's one time, it's a snapshot. It doesn't, that longevity there seems kind of sketchy. The question I had though is I don't see
sure. Yeah.
So how do you capture those? You know that they're happening and fix those, because Microsoft is notorious for creating new errors.
Yeah.
We updated your browser. Oh, we've got 5 new JavaScript errors. Thank you
Yeah.
very much.
There's quite a few libraries out there that basically you just sit on your page and listen for events like errors, and then they just do like a AJAX request out to some other thing and just basically log that bug.
We do that now, but is there?
Something better than that? I mean, really, it doesn't come down to the build level. I mean, it would all be runtime. So obviously, if your code compiles, then it's syntactically correct. It'll try to run. So it's up to the browser to interpret that. And if that fails, then there's not much you could have done at the build stage, other than if you knew what the bug was. In which case, somebody might write it like a transform to patch it if Microsoft is slow about it. But does that help answer, or a little bit?
On that note, you gotta remember we're working with JavaScript here specifically, and a lot of times that's going to rely on stuff that's going on in the browser, so user interaction, user input, and these things will be impossible to catch at compile time. You just won't know. So one thing to look into is like front end actual testing. So like Selenium, you can basically write tests for what you're doing, and that will run through a click and run through what it should be doing, and that will report back errors to you.
So we see errors like they'll handle, like the browser will handle itself gracefully, and then they'll become more stringent.
Oh, yeah.
And then it doesn't handle it gracefully. Or
Yeah.
they introduce new errors, or like we've seen some errors with Edge that are handled in the other browsers.
Yeah. Yeah, I think at that point, you're really up to people noticing that they changed it, and writing things to fix it. Yeah, I'm not sure a way around that, and especially Edge, because it's so changing constantly. You're probably going to run into that.
We're hitting about 1 a week right now with Edge.
Yeah.
Seems like.
Yeah, that actually seems pretty low.
Well, I mean, to speak to that, you know, like someone mentioned Selenium, like if you don't like that, it makes you gay. There's some really nice, like, what I would call sort of reformed JVM world things built on top of Selenium. So like Gem is based on Ruby, and there's other ones for Scala World and whatever. And just make those same tools that do the thing you really want, do it in a less ugly and difficult to manage way. So if what you really want is functional testing, like you want something that fires up the browser and runs your app, that's probably the only way to get it.
I mean, you're talking about builds. I thought maybe there was something out there that was instrumenting JavaScript and put in reporting or something like that, or So one of the things that people are notorious for is not actually putting in good code on its own.
Yeah. I mean, you could do some like trying and catching errors. Like it might be able to do like every time you do a function call, basically wrap it in another function that makes sure that it works. But you probably end up with some nightmarish code that you wouldn't want to deploy.
And are you talking like browser APIs that might not be supported, or actual like messes within the JavaScript code, like this variable just doesn't exist, or that
No,
object doesn't exist?
it's actual changes within the actual JavaScript compiler itself, as though things change within the actual engine itself.
Like
Um,
the interpreter changes.
Yeah, it changes, and then so something that was working doesn't work, or they change how something works. So
Right.
you see things between IE 11 and Edge. There's some big changes.
Interesting. Yeah, I guess
Yeah, and
I'm
that-
at a loss. Heck, there might be something like if it's an actual, if it's using some ancient like API that just doesn't exist anymore, or is deprecated beyond all reason, and Edge finally called it quits on it. There might be some packages out there that alert you at, hey, you're using some really old functionality. This modern JavaScript does not do this anymore. There might
Yeah.
be. I don't know.
Yeah, there probably actually is that. Yeah, something that would at least know what is deprecated in the JavaScript standard and throw an error. That's probably built into some linters.
Yeah. I don't think so.
But
Do you have a specific example of something, or, I mean, it's probably deeply arcane, but Sorry, Jeff.
It's usually code that we wrote poorly, then worked prior, and now doesn't work.
Yeah, maybe they were fixing bugs.
And this might be a terrible suggestion, I don't know, but you did mention, these don't quite seem fitting for enterprise. And to a certain extent, I can agree with you there.
Yeah.
And again, this suggestion might come across with disdain. TypeScript is something that could be up your alley. It's made by Microsoft. You get some strongly typed functionality out of it. I could definitely see that be more fitting in the enterprise. And that will definitely, since that will compile down, and that will certainly catch a lot of bugs for you. Just a suggestion, just throwing it out there.
Any other questions? All right.
All right. Thanks, Brandon.
Yep.